Alright, we're going to look at some perimeter and area of cones, pyramids, and spheres, and cylinders. And I should put and spheres up here. Alright, some definitions. We're going to go over a few of these that you probably already know and some may be new. Circumference, as we know, is the perimeter or the distance around a circle. Vertex is the point where all the lines come up in a cone and meet at a point or in a prism, in a triangular prism. That's called the vertex. A cone is a solid three-dimensional figure that has one vertex and one circular base, just like this. And I've drawn some examples for each of these. Cylinder is a solid three-dimensional figure with a curved side and two circular congruent bases that are parallel planes, just like what we think of a Pringles can or a vegetable can. Sphere is a three-dimensional solid that is perfectly round. An example of this would be any kind of ball, and it's going to be shown like this. Even though it's a 2D, I'm going to try to make it as 3D as possible. This line here, solid line in between, is being the diameter of it, what the space goes all the way across. And the last one is a prism, the three-dimensional figure named for the shape of its base. For example, if we have a triangular prism, you know the base is in the shape of a triangle. A rectangular prism, the base is in the shape of a rectangle. All right, let's look at some formulas. First, we have some very important concepts to look at before we get into the formula piece. The very first very important concept is the volume of the number. A volume is the number of cubic units needed to fill the space inside a three-dimensional figure. Remember, when we're talking about area, we're talking about square units. When we're talking about perimeter, we're just talking about units. Now that we're getting into volume, and you've already done this before, you're talking about cubic units. Very important concept number two, anytime you see a big B in a formula, that big B in a formula stands for the area of the base in a three-dimensional figure. For example, if I have 1/3 big B times H, that means the volume is going to be 1/3 area of the base times the height of the three-dimensional figure. Very important concept number three, any three-dimensional figure with a vertex or a point will be multiplied by a 1/3 because it is going up slightly to form a point, and that's going to be 1/3. So it'll just be 1/3 the volume of a cylinder. Okay. So if we look at the volume of, and we're going to look at the volume of all these different things. The first one we're going to look at is the cone. You've got the circular base, and then here in the middle you've got the radius, and you're showing the height from the very center of the cone to the middle of the circle. So it's going to be volume equals 1/3 big B times H. That is going to equal to 1/3, and we know that the area of a circle is going to be pi times radius squared. So we're going to substitute in for big B, pi times radius squared, and then multiply H times the height of the figure itself. In number two, you have the volume of a cylinder. The volume of a cylinder is big B times H. Now, we've already said that a cylinder is like a Pringles can. It's got two parallel planes that are circles. And so we know that the volume here is going to be pi times radius squared, okay, because that is that's going to be the base that it stands on, times the height. So that's just going to be big B times H. Notice there's no 1/3 there because it has no vertex in a cylinder. In the third one, which is our pyramid, it does have a vertex. So this is going to equal 1/3 big B times H. In this case, if I look at this one, this is going to be a rectangular because this is the bottom of it is in the shape of a rectangle. It's going to be 1/3. That area is length times width times the height of the entire prism itself, pyramid itself. So there's where I get my length times width. The triangular prism is like this. It has a triangular shaped base. Therefore it is called a triangular prism. That volume is also the 1/3 big B times h. This time, because my base is a triangle, I'm going to say 1/3. I know that the area of a triangle is 1/2 base times height. And then I'm going to find the actual height of the three-dimensional figure. In a sphere, or that shaped as a ball, this is totally different. This volume is going to be totally different than any of the other ones. It is going to be 4/3 pi radius cubed. So this one might be one of your new formulas that you will have to memorize. So the volume of a sphere, the inside of a ball, if we had a beach ball, the volume would be 4/3 pi, which is 3.14, what we're going to be using with these, times radius cubed. All right, let's do a couple of these, and I've set all of these aside so we can do them together. I know that the volume of a cone, because it has a point or vertex, is 1/3 big B times h. I know that my base is a circle, so I'm going to say 1/3. Big B is going to be the area of a circle, which is going to be pi times radius squared. And the height here is going to be 12 centimeters, so times 12. Okay? Now, in this case, I know that my radius is going to be 8, so let's go ahead and just put an 8 in here because 8 has to be squared. Now, I like to always keep numbers as low as I can. So I'm going to look at this and say, what is 1/3 12? Or I'm going to say 1 times 12 is 12. Divided by 3 is going to give me 4. So this is going to be 4 pi. 8 squared is going to be 64. And I know that 4 times pi times 64, I've already done these on another piece of paper, is going to give me 803.84. 803.84 centimeters cubed, because I'm going to say centimeters squared plus that centimeter is going to be centimeters cubed. It's said to round to the nearest whole number, so this will be 8,804 centimeters cubed. So that would be the answer to this cone. Now let's look at this one. This one tells me that the radius is going to be 10 for my circle. But now, instead of showing me this middle height, it is showing me the side of the middle height. So now I've got to take what I have learned from the past and to work this. I know this is a right angle. And if I want to find this side, the length of this side, I know that because this is a right angle, this is going to be my hypotenuse. So I have to go back and use a squared plus b squared equals c squared, which you should know by now is the Pythagorean Theorem. I know that a is going to be 10 squared plus, do not know what b squared is, that's what I'm trying to find. C squared is going to be 17 squared. Now in this case, I'm going to have 100 plus b squared equals to 289. And when I subtract 100 from both sides here, I'm going to come up here and finish this off so you can see it a little bit better. B squared equals 189. Well, when I found the square root of 189, I know the square root of b squared is b. It gave me something in the realm of, let's see, 13.74. And I rounded it to the nearest hundredth. I'm going to round this to my nearest tenth, to my nearest whole number. So I'm going to let b equal to 14. Okay, and I'll let you know whenever you need to do that. So I have now found the height of this is 14. Okay, now I can find the volume of this cone, because I know that volume equals the big B times the h. I just found the h, which was 14. I know that the big B has got to be the area of a circle, which is pi times, this is my radius, which is going to be 10 squared. I know that 10 squared is 100. 100 times 1400 is going to be pi times, let's see, 1400. Okay, and that's going to be times 3.14, which is going to be right at, and I'm apologizing for looking at my notes, but I have to. This is going to be 349, 439.6, okay, and I'm going to say 1/3, let's see, I forgot the 1/3 here, times 1/3 that. So what is 1/3 of 439.6? When I find 1/3 of that, I get 146.5. I'm going to just give it in case you all have got your calculators out. Centimeters cubed. Well, it says to round to the nearest hundred, so I'm going to the nearest whole number, so this would be rounded to the nearest whole number of 147 cubic centimeters. And again, do not forget that 1/3 because we're dealing with an area that has a vertex. All right, let's look at some prisms here. I have the height of this prism is going to be 5 feet. The base here is going to be a rectangle because one side is 8 feet, the other side is 9 feet. It's not a perfect square. So I'm going to say volume equals 1/3 the big B times the height. 1/3 is going to be 1/3. If I know this is a rectangle, I know that the area of a rectangle is going to be 8 times 9. And the height of this is 5 feet, so it's going to be 5 feet. Now 1/3, I can see in here that I can take 1/3 of 9, okay, because I'm having to multiply all that together. If this were a plus or minus, I would be distributing to everything, but because I'm multiplying all of this together, I'm going to find something I can find 1/3 of. And I know 1 times 9 is 9, divided by 3 is 3, so I know I can say 8, okay, 8 times 3 times 5. 8 times 3 is going to give me 24, and 24 times 5 is going to give me 120. Okay, 120 feet cubed. Okay, because we are talking volume and it is cubic feet. So 24 times 5 is going to give me 120. So that will give me my volume. Here I've got a base that has all of its sides are alike and it's 4 sides, so I know that it's going to be a square. So this is going to be a square prism, which is going to be the same thing, 1/2 or 1/3 the base, which I know is length times width or side squared, times the height. I know that 1/3 of 6 times 6 times the height is 7. 1/3 of 6 is going to give me 3. Of course, again, I'm trying to do this. Could you multiply all the whole numbers and then divide by 3? Exactly. But here I know that this 1/3 of 6 is 2, so 2 times 6 is going to give me 12. 12 times 7 should give me 84 inches cubed. So that would be the volume there. Again, you can always say 6 times 6 is 36 times 7 divided by 3, and you should still get 84 inches cubed. This prism is going to be a triangular prism. So we're going to start with the very same thing, and I'm going to scoot this board over a little bit. I'm going to say the volume equals 1/3, because we do have a vertex there, the big B times the H. 1/3, okay, times, now look at my base, it is a triangle. What do we know about the area of a triangle? Let's go ahead and write that down. It's going to be 1/2 the base times the height. Then I've got to multiply it times the height of the entire 3D dimensional figure. So I'm going to say 1/3 times 1/2. I know the base of this triangle is 12. and the height of that triangle can be 9, and the height of the entire three-dimensional figure is 10 centimeters. Okay? So again, I like to kind of get smaller numbers to work with. I know that 1/2 of 12 is going to give me 6, so I know that 6 times 9 is going to, well, and here I could just put this as 1/3 of 9 is going to be 3. So 6 times 3 is going to give me 18, and 18 times 10 is going to give me 180 centimeters cubed. And I have to write it as cubed because it's always going to be cubed. Alright, so here what I did was I found a number that I could multiply 1/3 into evenly, which was 9. That gave me 3 left over. I could half 12. That gave me 6. So now I don't have to half and find a third or a half of anything anymore. I can just multiply 6 times 3 times 10. And that's how I got 180 centimeters cubed. Now let's take a look at a cylinder. And you've probably done one of these before, but be careful. This doesn't have a point, so my volume is going to be big B times H. That means I need to find the volume, or I need to find the area of that circle. And I know that the area of a circle is pi radius squared, and then I'm going to multiply it times the height of the cylinder, which is, in this case, is going to be 12. Now, I have a diameter of 10, and you should know by now that a radius is just half of the diameter. So half of 10 is going to be 5. So we're going to say pi times 5 squared times 12. 5 squared is going to be 25, so I've got pi times 25 times 12. And that should come out to be, in this case, that will come out to be, and I'm using 3.14 for my pi's, by the way. That will come out to be right at, let's see, 942 centimeters cubed, because it is the volume of a three-dimensional object, and volume is always in cubes, so it's going to be 942 centimeters squared when I multiply all that together. Again, don't forget we're using 3.14 for the pi. Now I've got a sphere. Now remember, this might be a formula that you have not used before, but I should know by now that the volume is going to be 4/3 pi radius cubed. Okay? 4/3, let's go ahead and just write that down. I know that pi is going to be 3.14. The radius here is already given to me is 7 centimeters cubed. I can say 7 times 7 times 7 in this case, or 7 cubed, should be 343 times 3.14 times 4/3. Now in this case, I'm going to look at it and say, okay, what is 4 times 3.14 times 343? Take that, all of that product, all that I get that when I multiply it together, and divide it by 3. And when I do that, I get a number that is 1,436.02 centimeters cubed. In this case, I do want to change it into a whole number, so I'm going to let this equal to 1,436 cubic centimeters would be the volume inside of that. If you think of this as a beach ball, that's how much air that would be able to fit inside the beach ball, a volume of 1,436 cubic centimeters. Now, in this particular case, and I'm going to scoot this over a little bit, it gives me the diameter. I'm still using 4/3 pi radius cubed. Okay? The radius in here, remember, is half of the diameter. So the radius from here to here is now going to be 5 because half of 10 is 5. So I'm going to come over here and say 4/3. Let's go ahead and change that pi to 3.14 times 5 cubed. Okay? I know that 5 cubed is 125 times 3.14 times 4 over 3. Now this is like putting these all under one, okay? Now I'm going to say 4 times 3.14 times 125. Then I'm going to divide it all by 3, and when I do that, I get, in a calculator, and you should have a calculator with you, 523.3 repeating centimeters cubed. Now, I want to change it to a whole number. That 3 is going to keep 523 into cubic centimeters as my whole number. So that particular sphere will have 523 cubic centimeters of air that could go in that beach ball. How are we ever going to use this in real life? Well, we don't have igloos where we live, but they do in Alaska. I know some guys that have gone fishing up in Alaska, and they live in an ice house. Same thing. This one is going to be an igloo, has a diameter of 14 feet. What is the highest point of the igloo, and what is the igloo's volume? So they're asking me two things. The first thing I'm going to tell you is, let's draw an igloo. Now, you don't have to be specific, but I know an igloo, and here's the ground, okay? It has a little door so people can get into it, and it's got blocks if you want to go to that in that particular way. It's got blocks of ice in it, just like the concrete we use. This is my igloo. Now, it says that the diameter of the igloo from this point to this point is going to be 14 feet. Okay. The first thing I know about an igloo is that it is half of a sphere. So if I were to take this and go around and around and around and around like this, I know that if the diameter this way is 14, the diameter this way is 14. So I know that the height of this, or its diameter, or its radius, should be half of 14. So if I'm looking at the volume of 14 from here to here, should be half of 14 is 7. So I've already answered my first question. The highest point is going to be 7 feet tall inside that igloo, okay? And you might think, ooh, that's awfully short, but for the people that live in igloos, listen, remember, they're not gigantic people. So we're going to have 4, the 7 is going to be the height, the highest point of that igloo. Now we're going to say 4/3 times pi times radius cubed. And I know if I'm finding half of this, the 7 just happens to be my radius. So it's going to be 4/3 times pi, which is 3.14. Radius is 7, which is going to be 7 cubed. And I already know that this is going to be 4/3 times 7 cubed. This is going to be 343 times pi, 3.14 times 4/3. Okay? So when I multiply all this out, I understand that I have got something here that is going to give me 1,306 feet cubed. Okay. Now, I have found the volume of the entire circle, don't forget. So what have I got here? An igloo is half of the sphere, or half of a circle. So I have to take this piece of it and multiply all this by 1/2. So I'm finding half of 1,436. So half of 1,436 is going to be 718 feet cube. So if somebody is actually living in there, they've got 718 cubic feet of area to put things in. However, you have to remember your tallest point in this igloo is only going to be 7 feet tall, so you have to be careful of what you can put in there. And we're going to be doing other stories like this along the way, talking about silos and things of that nature. So make sure that you listen first as you go through this, and then go back and write down these formulas as I work them.